Welcome back to CognitionChunks. Yellowstone Day 6 Part 2. Unfortunately, this was a rainy day where we spent more time in the car than on hikes. First, we drove from Mammoth to the Petrified tree near Tower Junction and passed by the Roosevelt Lodge, which was closed for the season. The Petrified tree in Yellowstone National Park is a striking example of a fossilized tree. This phenomenon occurs when plant material is gradually replaced by minerals, turning what was once wood into stone, typically silica. The process is known as permineralization and can take place over millions of years. Formation process. Living tree. The process began when a living tree was quickly buried by sediment, such as volcanic ash or river sediments. Anaerobic environment. Deprived of oxygen, the organic decomposition was significantly slowed down, preventing the tree from decaying completely. Mineral infiltration. Groundwater, rich in dissolved minerals like silica, the same substance that makes up quartz, seeped through the sediments and permeated the woody tissues of the tree. Replacement. Over time, the tree's cellular structure acted as a template for mineral deposition. Cell by cell, the organic material was replaced with minerals, preserving the structure of the tree in stone. Exposure. Geological processes eventually exposed the petrified trees to the surface, where they are discovered today. Geologic time frame. The petrification of trees in Yellowstone is believed to have occurred during the Eocene epoch, approximately 50 million years ago. The petrified tree of Yellowstone stands as a silent testament to the dynamic and ever-changing nature of Earth. It's not just a stone representation of a tree but a natural archive that has captured a moment from the deep past, allowing us to glimpse conditions in an era long before human beings walked the planet. The physiology of mountain goats, Oriamnos americanus, is specially adapted to survive in the rugged, mountainous environments where extreme conditions are the norm. To understand their remarkable adaptations, it's useful to compare them with other animals that thrive in extreme habitats. Let's explore several physiological traits of mountain goats and compare them with similar traits found in other extremophiles. Skeletal and muscular adaptations. Mountain goats, they have powerful limbs with large shoulder and neck muscles that help them climb steep slopes. Their cloven hooves have a hard outer rim and a soft, concave underside that acts like a suction cup for gripping rock surfaces. Ibex, similar to mountain goats, species like the alpine ibex have specialized hoofs for climbing. However, ibex tend to inhabit slightly less precipitous terrain compared to the sheer cliffs favored by mountain goats. Snow leopard. While not a hoofed mammal, the snow leopard exhibits similar prowess in navigating rocky alpine environments. It has a robust build, long tail for balance, and wide paws that distribute its weight better on snow. Thermal regulation. Mountain goats, they have a thick, woolly coat that provides insulation against cold temperatures. A double layer of fur, with a dense undercoat and longer guard hairs, keeps them warm in winter. Polar bears. In a different kind of extreme environment, polar bears have a thick layer of blubber, in addition to a dense fur coat, to insulate against Arctic temperatures. Their fur is also translucent and can appear white to blend into the snowy environment. Camels. Adapted to the extreme heat of desert environments, camels have a series of physiological and behavioral adaptations to regulate body temperature, including a thick coat that provides shade and insulates against heat. Metabolic adaptations. Mountain goats have a slow and efficient metabolic rate that conserves energy when food is scarce in winter. They can subsist on low-quality vegetation due to their specialized digestive systems. Tardigrades, also known as water bears, tardigrades can survive in extreme environments including space. They enter a cryptobiotic state to reduce metabolic activity, which allows them to survive freezing and dehydration. Camels, their ability to withstand long periods without water is due to a suite of metabolic and physiological adaptations, such as reabsorbing water from their breath and tolerating high body temperatures to avoid sweating. Respiratory and cardiovascular adaptations. Mountain goats, their cardiovascular and respiratory systems are adapted to the thin air of high altitudes. They have a large lung capacity and high hemoglobin content in their blood, enabling efficient oxygen uptake. Bar-headed geese. These birds can fly at altitudes over 29,000 feet, higher than Mount Everest. They have a high affinity for oxygen uptake, which allows their blood to transport oxygen effectively even at low atmospheric pressures. Pika, these small mammals live at high altitudes and have a high surface area to volume ratio in their lungs, which increases oxygen absorption. Reproductive adaptations. Mountain goats, they breed and give birth in high altitudes, which provides natural protection against predators. Their young are precocial, able to stand and move around shortly after birth, which is essential for survival on precarious cliffs. Emperor penguins, in the extreme cold of Antarctica, emperor penguins breed during the harsh winter. They have unique social and physiological adaptations, such as huddling for warmth and fasting for long periods while incubating eggs. Sensory adaptations. Mountain goats, while specific sensory adaptations are not often highlighted, their vision is essential for navigating rocky terrain. Like other prey animals, their eyes are positioned to provide a wide field of vision. Fennec fox, adapted to desert life. The fennec fox has large ears that dissipate heat and enhance hearing to locate prey beneath the sand. In each of these examples, the animal has developed unique adaptations that are best suited to the specific challenges of their environment. Mountain goats are a prime example of evolutionary specialization, with their entire physiology molded to survive where few other large mammals dare to tread. Mountain goats, due to their hardy nature and high-altitude habitats, have fascinated human cultures for millennia and have often been imbued with symbolic meanings and mythological significance. Their presence in mythology and symbolism varies across different cultures and geographical locations, and these animals are often revered for their agility, strength, and resilience. Amongst certain Native American tribes, the mountain goat is seen as a figure of respect and is often associated with hunting. The sure-footedness and agility of the mountain goat make it a symbol of guidance for paths and journeys, both physical and spiritual. They are also considered symbols of status and abundance. In some Pacific Northwest tribes, mountain goat horns and wool were used in ceremonial dress and headwear, indicating a person of high rank. Thank you for joining us for another CognitionChunks episode. Please like and subscribe.